In this video we're going to talk about casting, and casting is where you take a variable or an item and you turn it into something that it isn't. It'll make a little bit more sense as I walk through some examples here. So I'll start with just simple integer examples. We'll make int equal to 7, and as we know, if we print out x, we'll get the answer 7 here. Now, if I decided that I really wanted that 7 to be, let's say, a decimal. I really want it to print 7.0. I want it to become a decimal. I can force it to print out or to output as a double if I'd like by putting the word double in front of it in parentheses. So if I were to throw, I'm going to add a comment here, if I were to throw double in parentheses in front of a variable, it basically will force it to be a decimal. Okay, it'll force it to be a double variable. So when I do this output here, you will see that it will actually print out as 7.0 now. Now that didn't actually change the variable at all. If I do an output here and put an x and just output x one more time, then I can see that it is still 7. So this isn't going to make an error at all because the integer is still 7. But here I just told it to print it as a decimal, and down here it just says, hey, go get the 7 again. Now, if I wanted to actually change what x was, I wanted to permanently change it to a decimal in a sense, well, I would have to set up a double variable. Maybe I'll call it y, and I will set it equal to this cast x as a double. And so what I've done here is, and as you can see, is I'm going to output just the x here, and then I'll output just the y. So I'll output both of those, and we'll run this to get new output at the bottom. And you can see that the x is an integer, and the y is a double, and I forced it to become 7.0. Now, you might know that the cast that I just did doesn't make even a lot of sense because doubles I could just do double y equals 7, and remember that this is an integer 7, but when we create a double it's forced to be a decimal anyways. And so when I output this, when I'll run this, I still get 7 and 7.0. No big deal. Okay, but let's kind of flip-flop there for a moment, if you will. Let me start fresh on these. Now I'll create this double, and I'll make the double equal to 5. But let's give this name a name A. Okay, so A is equal to 5. Now, let's say I would really like that to output as just a 5, and it won't right now because, of course, it is a double, so it's going to print as 5.0. But if I want to force it to become an integer, I can do cast it as an integer and just throw int in parentheses in front. Okay, so that forces an integer to be output. So if I run this, you will get the actual 5 instead of 5.0. And of course, if I were to change the double here to something like 5.7, now remember, we would integer, it's going to cast as an integer, and if this number were to become an integer, it simply drops the decimal. It is not rounding, it simply just drops the decimal. So this one is also going to output 5. So it's very important to realize it's not rounding. Casting as an integer just drops all decimals. If I go 123.9 and I run this, it's going to output 123. So those are some important things to understand, that when you can cast as different data types, you can convert them to different data types, if you will. Now, something that a previous video of mine or another video of mine has discussed is the dangers of mathematics, especially when you have integers. If I have int x equals 2 and y equals 7, and I want to simply divide those numbers. I'm going to go I'm going to go y divided by x, which is 7 divided by 2. Okay, it's very important to realize 7 divided by 2, mathematically speaking, is 3.5. But this is not going to print 3.5. A reminder, or if you haven't seen my other videos, is that if you have all integers in your problem, then the computer is going to output in integers. So 7 divided by 2, we know is 3.5. But it says you used all integers, which implies you want an integer answer. So the answer here is going to be an integer, and so they're going to give me an incorrect math answer, and they're going to give me 3. Now, to solve that problem, there are some things that you can do, and casting is one of them. Now, if either y or x is a decimal, then you will get an actual decimal answer, because remember that Java will use the most precise data type that you have. So if you were to cast one of these as a double, so in other words, what this does is it says we're going to make y a decimal. So this is actually 7.0. And so I'm going to add a comment here so you can realize this is actually telling you to do 7.0 divided by 2. And remembering that now that there's a decimal in my problem, this can handle decimal answers. So it's going to give me the answer 3.5 in this case. And now I have the answer I'm looking for. So casting as a double may be beneficial if you're working with integers, but you still want to be able to get a decimal answer. That's possible. Now, you have to be a little bit careful here, because issues can arise. If you throw parentheses around this whole math problem, y divided by x, now you have to remember that order of operations apply. So in this case, you need to realize that y divided by x is done first. So 7 divided by 2 is first. That's 3.5, but these are all integers, so it says 3. And then it casts 3 as a double, and the output here that you're going to get is 3.0. And it's not the right math answer. So casting can be a little bit tricky. You need to make sure that you're very, very careful in where you place the cast. So in summary, just remember, casting is basically where you use things like int in front of something if you want to force it to become an integer, or a double. You put a double in front of something if you want to force it to become a decimal. And those are just two basic uses of casting. When you get into more advanced programming, you can cast as other data types. Hope that helps, and I hope you find this beneficial.